All right. Good evening, everybody, and welcome to the first ever in real life Consulting Projects Ant event. I'm so glad to finally see your real faces for the first time on this event, but I already know a lot of you. I think it's just so much nicer to have this event for the first time in real life. So I'm very grateful that we're here. So, it's not working.
We have the technology.
We just don't know how to use it.
Alright, so what are we going to talk about today? Of course, it's a consulting journey. It's a final opportunity for our consultants to talk about the things they've done for their clients, how it went, what their experience was as a consultant in their respective data science and AI problem. We're going to have 3 presentations, or actually, we're going to have 6 or 5. So we're going to start with .dash, a project that was supported by HighMind. Now it's Brightwell's Digit, but more on that later. So when the people from HighMind arrive, they are going to give a short presentation on their consultant firm, and then the people of .dash will dive into the project. Then we go to Condacor, which was supported by BrainJar, and we'll end with our first 1-year project, the CSI Business Consulting Project, which was supported by Moebius, and Moebius will also present their firm. So we have a lot in store for you. For the people that don't know the concept of emergent consulting projects yet, I think this picture really summarizes how it works. We have 3 important stakeholders, clients, partners, and students. So we have small groups of students that work together on a project for one of our clients, and they are supported by the expertise of our partners and Emergent. We are in the middle to actually bring everyone together to have this really nice experience. What do you have to keep in mind for this? So we have these groups of 5 students. They work for 8 weeks, very, very hard on their projects, and I'm very excited to see the results they brought. And of course, they had some nice workshops that we gave them, that our partners gave them to support them in this process. So that's enough talking for me. I'm going to give the floor to the first team, which is .dash. So please, .dash, come forward and let's have a look at your great presentation.
Hello everybody, my name's Ethan and I had the pleasure of working with .dash for this project. This briefly goes over our wonderful team and some colorful nicknames. It was Isa, Rishi, Vaishnav, Simon, and I were the ones who were in charge of it essentially. So the project itself, we had all of this mergers and acquisition data. And with it, we were posed the question, how can we leverage knowledge graphs for mergers and acquisition data? We decided we would explore the data and establish an infrastructure, use that to predict mergers and acquisitions, and then develop a recommender system. But fate had other ideas in plan. We decided we'd just go for one thing well, then create a bunch of garbage. So we decided to do what we could with the weeks we had. It is not. So. Yeah, so essentially with the project infrastructure, there's 3 key portions that we had to work with, was Pandas, Azure, and Neo4j. Pandas is pretty simple, but Azure is all in Linux, and Neo4j is in Cypher, so that was a bit of a learning curve for a lot of us. So essentially in the data exploration phase, we had a CSV of 5,000 Belgian companies. 2,000 acquisitions between 1987 and 2022, and then information on 230 of those acquired companies. And essentially, also within this, not only was it a 5,000 row data frame, but it was a 850 plus column data frame, so, you know, like a lot of features to it. So when we first did the data exploration, we looked at just seeing if we can predict merger and acquisition, treating the acquisitions as like a 1 if a company makes an acquisition, and a 0 if that company doesn't make acquisitions. So it was a very basic problem, and we just fed all the features in there, and we still like, from it there's a bit of a pulse where we had like, as you can see in the bottom left corner, like 0.62 precision, which is okay, but you know, it's more of a baseline model. Then when we looked at mainly the idea between doing that first baseline model was also to look at what features were contributing most to the variance. You can't really see it too well, but what you want when you do feature exploration like this with like a baseline model is you want like a couple features that really explain a lot of variance, and instead we got a lot of features that explained a little bit of variance, and they all came from a similar thing, which was personnel. So it kind of smells like an artifact, and we just moved on with feature exploration in a different way. But we established a machine learning problem that we can go back to with further feature creation if we want to really improve that and figure out what consolidation of information really explains variance well. So instead we just decided to take a more theoretical route and look at like an article that explains what features would be good if you're assessing a mergers and acquisition, just because intrinsically we were having issues figuring out those features. So we found income, profitability, and assets. So we just kind of moved on with that. Yeah, so then within that, we have this beautiful knowledge graph, which we ended up creating. So essentially we have all of our companies, the 5,000 companies, and we have the 2,000 acquisitions between a handful of these companies. And then what we decided to do was create varying levels of either sector information or location. So for sector information, these are like NACE codes, which is like the most broad being like a code for agriculture or something. And then we did a similar thing for location, zip code, etc. And then this is how it was implemented. We were actually able to implement it well in Cypher, like no real issues there. But then, yeah, so if you kind of look at it, the blue dots represent the companies, and then you can see, like at the top there, there's that cluster with a lot of companies belonging to a certain location and sector. And then within some of these companies, there's acquisition ties. So that was our big deliverable with it. But essentially from there you can go more in depth where you incorporate macroeconomic data into like different sectors and things like that, and you know, really leverage the power of a knowledge graph where you have all the nodes created, so now you can insert data in the relationships. You can also, we also thought like adding dynamic data would be a good call because it's more realistic to model mergers and acquisitions over time. Yeah, and then also understanding what the role of the knowledge graph would be if we wanted to do like link prediction per se or query within the knowledge graph to increase features, for example. So yeah, that concludes the project we did. And because this isn't something we got paid for and it's not something we did for school, it was just something to be better data scientists with. It's good to kind of reflect. And I think we got, in the future, we should be better at being confused when appropriate, because there's our technical people went for very technical problems and kind of left people without technical experience like out to dry. So we should have consolidated better in that way, I think. We ran into a bunch of bottlenecks where like we'd spend multiple weeks setting up like Azure or something, and then afterwards we'd just do all the machine learning like locally, and then we could have done those like parallel, for example. Yeah, and just kind of keep up with everything every week. All right, that concludes it. Thank you.
Yes.
President of Emergent.
Okay. All right. So that concludes our first presentation. And now I would like to give the floor to Simon from HighMind, or as it's called now, Vitals Digit, so that they can present the firm they are currently now. So, Simon, the floor is yours.
All right, thank you. This one to change slides? All right, thank you very much, and thank you to the group for the good work they've done. As you probably know, we entered here as HighMind as a sponsor, but meanwhile, over this semester, we actually changed names. I want to take the time here to a bit explain this transition. So HighMind was, always has been actually a sister company or division of BrightTools. We decided to consolidate the name to have a more concrete offer to the market and stop confusing people all the time with what's the difference between HighMind and BrightTools. So what is HighMind, or as we call it now, BrightTools Digits, is the digital transformation in data branch of BrightTools. So what we stand for as a company, what we bring to our clients, is that we accompany them through their technological transformation journey. So we start with a digital transformation as they digitize documents and processes, they start automating things. But then, as you do that, you start producing data. So there we combine all the expertise to also help them with their data problem and make sure they have the right strategy, the right governance, and implement the whole data engineering pipeline so that they don't get stuck with a huge pile of data they don't know what to do with. And finally, as we help them with that, they have the data to finally start doing things with it. So it's organized, it's proper, they know what means what. A good example is the definition of a square meter in real estate. Not two people know what it actually is. So when you have the right definition, everything stored properly, you can start working. And that's where the analytics transformation comes in. So when you start actually applying advanced analytics. So advanced, sometimes it's just a reporting, but to the board of directors, reporting on clean data is very important for decision making. But then you also have all the applications with the data that allows you to do all the fancy things as the projects you've been doing this semester, such as using machine learning, knowledge graphs, etc., to try to go the next step and use the data to create new insights, to create new intelligence for the company. As you are ready with that, well then it's the future, right? You can start transforming your business model, leveraging all that new knowledge and all the technologies that are emerging right now. So I try to avoid putting any buzzwords, so there's no NFT, blockchain, or metaverse there. But of course, it's the future. We need to see first how they deliver value to the companies, but we always need to be looking for that. So that's about what BrightTools Digit brings to the market. Another question you ask yourself is, what does it bring for me? So just to give a few examples of projects that we're doing, and it's just going over it rapidly, but of course after that we'll have time to chat, so feel free to come ask some questions to me or my colleague. So we really want to go from the business to the technical implementation. We really want to go over the whole spectrum. So the type of project we deliver can be from implementing a direct-to-consumer business model, so an e-commerce website for cars. So we all know Tesla sells cars online, but traditional manufacturers don't. So a traditional actor in the car industry wants to start doing that also, and we help him transform his business model to finally adapt to this. Of course, as you think, going from selling cars in shop to selling cars online is a huge path in terms of digital transformation, data, and all IT-related problems that they need to solve. Another one, facing basically also the new actors of e-commerce, facing the traditional retailers, how to help the traditional retailer to be fighting against e-commerce. So we helped one of the actors on the Belgian market to create a whole digital ecosystem with a complete omni-channel offering, so that they can accompany their clients and really get to secure that link with the client to really understand better what they need and serve them the way they want it. On a more purely data related side, we can think of helping a financial institution doing its data monetization strategy. So this is really strategy consulting. It's not pure data, but it's related to data. Or, and that is pure data engineering, is how to develop a big data platform from scratch for an actor in the healthcare system to solve basically the big spaghetti of data pipelines and reportings they have in every direction and have something consolidated. So that is another project. And more on the machine learning side, we think of optimizing the inventory for the supply chain of a logistics company, or, and the last one, which is actually my favorite, is computer vision for tracking of people and objects in the catering industry. The fact it's my favorite, nothing to do with beer, of course, because it's computer vision, but applied to beer. And so that's for the type of project. So of course, feel free to come and talk to us. We have more projects. We can give more details. Of course, here I want to keep it as short as possible. But I cannot talk about Brightwolves without talking about the culture at Brightwolves. So it's a very value-driven culture. All the values are written there, values that inspire. But it's also very entrepreneurial, very growth mindset type of culture where we want people to grow and learn all the time. And we want this to be basically a hands-on MBA, the best place for you to learn after university, because I think everybody here wants to learn. So that's the type of environment we try to create while delivering impact, feeling really that you're doing something worthy, and have some fun also, a lot of fun sometimes. All right, that's it for my parts.
Yes, thank you. That brings us almost to our next presentation, but of course I really want to thank the people from Brightwolves Digit, because they are our longest-lasting partner. They've been there since the beginning of Emergent consulting projects, which was the second semester last year. So really thank you for being with us for the whole journey. I think I can speak for everyone to say that they've always had a really valuable opinion for us to really improve and to get us at the point we're now. So thank you for that. But that brings me to the next project we have in store for you this evening. It's the Quantacorp project. So please give the floor to the people from Quantacorp.
So, I woke up one morning, I get out of bed, I go to my wardrobe, and something hits me. I'm a very boring person in terms of clothes. So I have a sudden bit of inspiration to get the coolest t-shirt, the coolest t-shirt I can ever imagine. But, before I can do that, what size do I get? I get my measuring tape out, I measure everything required, and then I order it online. Simple, right? But now, imagine in the not so distant future when Emergent has a community of 2,000 or 3,000 people. How are you going to do it then? You can't individually measure everyone. So let me introduce you to QuantaCore. Essentially, QuantaCore takes 2 photos, one from the front and one from the side. And just from that, it can tell you the exact measurements you need. Just from 2 photos. See how simple that is? So instead of spending all that time measuring those 2,000 people at Emergent, you could do it so much quicker. So, the first problem that we had, or the first problem that QuantaCorp has, a main problem, is that if there is neckline obstruction, the calculations is off. You can't detect how the circumference of the neck or circumference of the chest. The data is wrong. The model doesn't work. So what we had to do was we had to detect whether the neckline was obstructed. That was our task. That was our scope. The first part of this was to get data. And to do this, we go to Celeb HQ, which is a data set of 30,000 celebrities, and we filtered through all of them using an application that Chidi made. And what we did was we labeled it as short, medium, long, and discard. There was a lot of discarding in that data set. Yes, with that, that's the first step done, the data set. And I will pass it on to Diego to talk about our naive approach, our first approach to tackle this problem.
So moving on to the different approaches we've explored in order to solve our problem. So in order to detect neckline obstruction, we've explored different approaches to see which is best, of course. We ranged from low-level approaches to more high-level approaches, from naive to a classifier. In terms of the naive approach, the idea was to use our pre-existing knowledge of what an unobstructed neckline is in order to better design our and the general approach. So since we already have a data set of valid images and invalid images, we can use the invalid images, combine them to have a reference head, and then once we have that reference head, we need something to compare it to. In order to get the input image, you can already have an image of the head, or have the image of the whole body from which you find the bounding box of the head, and compare that with the reference head. In practice, how does it look? Well, first you have creating the head on the left. So we combine a set of some photos of valid heads where the neckline is not obstructed, and created this image where at least half of the images correspond to this. So this is a binary mask. If you don't know what a binary mask is, it just separates an image into 2 colors, black and white. Black is the background and white is the foreground, the object, what you're interested in. In this case, it's the silhouette. So now we have the reference head. How do we extract the face from, or the head area from a silhouette of the entire body? Well, we run it to the algorithm and we end up with this. And then we compare these in order to extract what we call a similarity measure. So we compare different areas, different regions of both photos and see if they have the same color. So if you take the top left pixel of each photo, it's a background on both. So it's a match. Likewise, if you take the middle pixel in both photos, it's the middle of the silhouette, so it's white as well. But there is a bit of difference in their general silhouettes, which is why you see a bit of black pixels corresponding to a mismatch. Nevertheless, the similarity is relatively high, 96.23%. Other examples we have here is another valid image, and then an image of a person who has long hair and has parted it one way. And we have determined a threshold starting from which every image is valid. Here it is around 92.5%. So here we can see that it correctly classifies an unobstructed neckline as such, and an obstructed neckline as an obstructed neckline. So here is what we call the confusion matrix, but I'll briefly explain what happens here. So in total we have 5 images of non-obstructed necklines at the top here, at the top row. And we can see that all of them have been classified as such, and there is no misclassification of actually non-obstructed necklines. But the obstructed necklines are mostly classified as obstructed with a tiny bit of error.
Yeah, so now we come to the segmentation approach. This is a very simple idea that gives us a very good performing model. So how would you conclude if the neckline is obstructed? You look at the hair, you look at your chin line, you take the bottom line of your hair, you take the bottom line of your chin, which are the red and the blue lines, and you compare those two. If your hair or the red line is above your chin, which is the blue line, you classify that as non-obstructed neckline. If it's vice versa, you classify it as obstructed. How we do this? We use pre-trained models for hair segmentation, which is the black and white mask. We use MediaPipe Googles. For that we use Celebi, was it? Celebi, yes. Celebi model, and for the detection of the bottom of your chin, we use MediaPipe Googles model. We stack those two on top, and that's how we extract the red and the blue line and conclude whether or not our neck is obstructed. Here we also see a very good performance. A lot of the images were correctly classified as being non-obstructed when they are not obstructing, and obstructed when they are obstructing.
So, luckily for you guys, the third approach is super simple. You need no background in machine learning to understand just basic classification. The way it works is that you have a data set of obstructed necklines. In our case, we had short, medium, and long. You feed that to a neural network, and it does all the magic for you. But we were even lazier. We took a pre-trained model. And let me actually explain what that is. Convolutional neural networks have 2 parts. The first bit teaches the network how to see, and the second bit teaches it how to distinguish between different items. So we took a network that already knows how to see, and we just trained the last few bits, which is a lot faster, a lot better, because kind of lazy people. And so we just downloaded a network that Google made. We put 2 layers on it. We gave it a data set we labeled. I think it took 10 minutes each for a solve. And we have a well-performing model. So if you think computer vision is hard, time to reconsider and time to actually try it. Because it's a lot less complicated than it seems. Obviously, from such a project, there are a lot of lessons learned. The first one is, do not reinvent the wheel. Like I said, there's tons of neural networks out there pre-trained. You don't have to come up with a fancy architecture. Take what exists and do the bare minimum to get to good results. And also, people like Google already made good models. I bet the odds are higher that Google knows what you're doing and you don't. So just stick to what exists. And obviously, quality over quantity. There was a lot of stuff we could have done that we just didn't do. We tried to scope ourselves to 3 different things and divided the work amongst the 5 of us. And we tried to make sure that that was done, and that Quantum Core can build further on this and make your product even better. Thank you for listening.
All right, thank you to the Quantum Core team for your very compelling story. I think that's very cool to see a computer vision project at Emergent. It really shows what great projects we've managed to see, and I think you did a great job at doing that. Also, thanks to your partner, Brainjar, who's unfortunately not here, for supporting you. I think you were a great guide as well. But now we move on to the last project, It's a project supported by Mobius, and first I want to give the floor to Peter, who's going to present Mobius to you.
Good evening, everyone. First, congratulations for all the groups already presented, but also I think for the CSI group that will present afterwards. I think I really liked the presentation, especially the learnings side. So looking forward to the learnings of the CSI team. I think we've met each other before virtually at the Data Science Soft Skills workshop. So let me still take the opportunity to present Mobius in a slightly different way and maybe highlight a couple of projects we're doing just to get you applying for a job. Okay, Mobius. You're probably wondering, Mobius, why do you have this symbol, the Mobius strip, the Mobius band? Well, it actually started with, and why do we call ourselves Mobius? It's by the way Mobius, not Mobius. Mobius comes from the legendary mathematician August Mobius, and he was called into a windmill that had productivity problems, and especially the belt, where the energy of the wind was transformed into the other components of the windmill. That belt wore out quite rapidly. So what August did, and we can call him August, but August Mobius, what he did was he came in and he analyzed the situation, and instead of changing the entire architecture, changing the entire design of the windmills, changing the fundament and so on, he really focused in on that specific belt. And I always carry a belt from a windmill with me. The belt actually was like this, right? You just have a belt, and because it turns so long and so fast, it wears out in the inside, right? So what August did was, after a lot of study, he just cut the band like this, and he twisted one side like this, and then he, it was not gluing, but he stitched the band again, to itself, let's see. And so we have again a band. Let me do this. I also, by the way, have always a stapler with me. So I'll quickly do this. By the way, everyone at Mobius has to carry a stapler. So he still has a band, but now by just twisting one side and making a very simple change, he was able to increase significantly the longevity of the band, the lifetime of that band. Why? Because if you turn it now, and you can still turn it, it's maybe not very easy to see, but if you turn it, you actually use both sides of the band. You can always try to, with a pencil, put a line, and you will write on both sides. So with that simple switch, actually, August was able to create a lot of impact, create significant value, and increase the productivity of the windmill. Not just because it was the band did not wear out as quickly, but also because the setup cost of changing bands and so on. You can imagine the implications of just a simple switch. So that's why our founders of Mobius actually took the name Mobius and also used it in our logo, because we believe that a simple switch can have a significant impact. So we're also looking for that simple switch in everything we do to make a great contribution. We also believe, and that's maybe also the symbol of the band, that there's a lot of synergy between the people, the customers of our customers, the people in the organization of our customers, but also the organization and the organizational structure, and the synergy between those three stakeholders, those three components are critical to implement a strategy. So that's Mobius. Let's see. So Mobius was founded 25 years ago as a spin-off of Ghent University. We're now with more than 100 consultants, and you're probably wondering, where is the data? Well, we're not a data company, we are a business consulting firm. So we're really focused on business consulting in a lot of sectors and on a lot of areas. You see them there, bottom left, goes from strategy, business models, over to sustainability, operational excellence, supply chain excellence, but really looking for projects where we can create an impact and where, with simple things, but in a different way, we can indeed make a difference. All right, maybe to make that a bit more tangible for you, let me show a couple of customers we're working with. I've probably already mentioned, I think last time we spoke, the reference we're very proud of, which is for Agentschap Zorg en Gezondheid. We've been asked by the Flemish government to support them with the vaccination strategy in Flanders. We did not only do the supply chain side, the IT side, but we also built an analytical model to allocate the different vaccines in Flanders and also determine where each of the vaccination centers need to be located. But I already mentioned that before. For Johnson & Johnson, we also do a lot of work. We're there to constitute the global supply chain analytics team. So that's myself together with Wart, my colleague, and a number of other colleagues. But that's the healthcare sector. We also do, for example, for industrial players like Barco, we designed the sustainability strategy and also set up a reporting structure to report on sustainability and environmental metrics because they're a listed company. We do operational excellence at Knauf. For Hubo, for example, we designed the strategy for an omni-channel customer experience. They have their offline stores, but they also wanted to set up their digital channel. How can that work in combination? So we designed that, and we also worked, for example, still working for a lot of cities and also federal government to assist with a lot of topics, like if cities want to cooperate. If, for example, in the Flemish government they want to have a new strategy for certain agencies, we are happy to support. But again, where is the data? You will ask. Let me maybe highlight two other things where the data really made a difference. First one is a project we did for a Belgian hospital where they have a lot of stocking rooms, so more than 150 stocking rooms in the hospital. And they want to know how optimally place all the articles in the stocking room. So today they're doing that manually to see, well, all these articles, so medical supplies, office supplies, how they fit into a certain tray and how they can fit it into one room. But of course they had to do that for more than 150 stocking rooms and for a number of sites for that hospital. So they asked us, can we do that more efficiently? Can we model that? So that's where we designed a model to come up with the optimal solution of placing all the articles in the stocking room with least spare space possible. And so to determine how much space they had, and those plans informed the architects, informed the building of those stocking rooms. So that's one where we got a general business question, but we had to translate that in a mathematical question and designed a model where you see some of the outputs here. Even a visual diagram of what needs to be stored where, how much spare space you still have. Maybe a second thing, and let me see, I also bring pointers with me. So the second, of course, the drivers.
Yes, it's working.
Okay. Another thing we often do is to design and model the network of large industrial and players and retailers. For example, you see there the network of a chemical player in the United States where they want to understand with all the customers and with all the products, with all the sales, where do we need to put our warehouses in the most efficient way? How many warehouses do we need and where do they need to be located? So we also made a model, a kind of digital twin, you can call it, where we modeled the flow of goods, where we were able to actually quantify the supply chain and also understand the bottlenecks and do some sensitivity analysis of if the company is growing with 20%, what else do we need? So network design, supply chain modeling is also something we do quite often. All right. Okay, I also bring batteries, but I don't think I need that. Okay. Yes. Of course, we are in search for talented people. We are also hiring. Yeah, feel free to meet with Walter or myself after this. But why would you join Möbius? Well, I think if you are interested in business consulting together with the strong data analytics side of it, I think yeah, Möbius is the place to go. We have values, like every company has values, but I truly believe that we breed our values. When I speak to colleagues who left Möbius, and people always leave companies, but when I speak to people that left Möbius, what they miss is the values. They did never expect that the values which are on the website and which everyone sees as a sales pitch were really lived by in our company. We have 4 values. Shoulder to shoulder. So we work together not only with our colleagues but also with the clients. And that's something that everyone says, but we truly believe that we do that together with the client. And we also equip them to do it on their own if we are left. Guts is the second one. To have the guts to try something else, to be, like we call ourselves, profoundly different, to do something new. But also, yeah, perseverance is a third value. Perseverance is doing the last mile. Don't stop before you have the cherry on the pie. So persevere, and finally touchdown. Make sure that you really deliver what the client needs and even a bit more. So those values are really critical, and we also hire for values. We hire for values, not for skills, and we coach people on those values. So those are really critical for us. If you recognize yourself in those 4 values, yeah, speak to us. You're probably wondering what else I have in my pockets. Let's see. I have business cards, so everyone who's interested to join, feel free to ask one. Okay? Thank you all.
All right, thank you, Peter. This brings us to the last presentation of today. I think it's a very special presentation because it's the Seaside Business Consulting team. They've been working not for 1 semester but for the whole academic year on this project, and I'm very curious to see what they delivered in the end. So please welcome the Seaside Business Consulting team.
Hello, everyone. We're the CSI Business Consulting team from last semester, the 3 survivors. For those of you who weren't able to attend last semester's event, just a brief overview. Our project is all about flight delays and kind of determining the cost. We looked at many different things, including calculating the expected cost of delay, identifying which flights are most risky for the flight network, as well as finding ways to quantify the cost of propagated delay. And the main problem that we kind of focused on, and something that airlines, I think, experience on a daily basis, is they have a flight that gets delayed initially. It has a primary delay due to things like weather, operations at the airport, or many different factors can contribute to that. However, flights don't just happen independently. Some of them share aircrafts, some of them share passengers, crew. So when an initial delay happens, it affects the entire network, not just that one flight. And this means the cost kind of explodes for the airline. They have to address all of these issues at once. So the 2 questions that we kind of looked at in this project is, number 1, how can we predict the total delay that happens when that initial delay happens? So what is the total propagated delay? And then number 2, how can we put a price tag on this? How can we quantify this cost? And these 2 questions, once they're answered, they kind of help us generate or create this tool for the airline that will ultimately help them make the most economical operational decisions real time. So if a flight gets delayed, they can sit down and make a decision on if they're going to delay other flights, if they're going to just rebook the passengers on a different flight, or many other options that they can take a look at. So there are kind of two different steps that we took in this project. Number one being looking at the calculation for total delay, and then number two, looking at the costs. I'm going to cover the delay calculations, and then Juan and Norbert are going to take over for the costs. So looking at calculating the total delay, there are 4 different factors that you can see that kind of impact what that total delay is. So probability that a primary delay will happen in the first place, as well as how many minutes that primary delay is going to be. Because for 5 minutes, that's not going to impact much, but if it's delayed by an hour or 2 hours, the rest of the network is going to suffer. Additionally, the flight schedule and impact on the rest of the network, as I mentioned, and then the number of passengers on each flight. Obviously, big flights are going to have a lot more passengers that are impacted versus smaller regional flights. So we first took a look at primary delay, calculating the probability of a primary delay happening, as well as calculating how many minutes that's going to be. And for this, we created a neural network model. We had about a dozen different parameters as our inputs, including day of the week or week of the year. As you all know, if it's Christmas Day or holiday season, flights are probably more likely to get delayed versus, in the middle of March or April. And then at our output, we had a softmax layer, which kind of generated a probability function for us for the probability of primary delay. So we had different bins for primary delays, 0 to 5 minutes, 5 to 10, and so on. So ultimately, at the output, we get a primary delay probability distribution that we can use. Once that was complete, we looked at the flight schedule and the impact on the rest of the flights in the network. And we did this by looking specifically at flights that either share aircrafts, share transfer passengers, or transfer baggage, and so on. And we calculated what we refer to as the effective delay. And many different factors play into it, including the primary delay of the aircraft, as well as the time that the passengers have to make the transfer versus the time that's needed to make the transfer. So, for example, if a passenger needs, let's say, half an hour to make a connection, and they have 40 minutes available, but their first flight is delayed by 15 minutes, they're going to be short 5 minutes, and the flight is going to have to be delayed 5 minutes. So in cases where this effective delay is less than 0, that means the delay is not going to be propagated. In cases where it's greater than 0, that means we're going to have to delay the second flight if we want the passengers to make it. And we took this kind of equation and created a little graph model that you can see here. It's kind of small, but we have an initial flight here, D83081, that's delayed by 147 minutes. And then everything to the right of that flight are all the other flights in the network that are impacted by that initial delay of just over 2 hours. So you can see that these first 4 flights are going to have to be delayed by 117, 107, 82, and then 52 minutes if we want all the passengers to make it. In some cases, obviously, you're going to make the decision to just book the passengers a hotel and give them a different flight. But assuming that you want all the passengers to make their original flights, this kind of shows the entire network and how many minutes each flight is going to have to be delayed by. So once all of those components were kind of calculated and generated, we could put them all together to calculate the total delay for each flight generated when it's delayed. And we created 2 different kind of components in our little tool that we made, I should say. So the first part is flight risk ranking, which essentially, up top, you can select a date that you want to look at, and you can load the network, and it will give you a list of flights ranked based on how risky they're deemed by our algorithm, with the number 1 flight being the most risky, which means if that flight is delayed by 10-15 minutes, it's going to cause a lot of other flights to be delayed versus flights at the bottom here. They probably don't have a lot of transfer passengers, so if they're delayed by however many minutes, it's not that big of a deal. And then the second part of our tool is what I showed earlier, which is generating the network. So we have up top, you can select which flight you want to look at, and then we have a little slider where you can select what you want your primary delay to be. So if the primary delay is 0, you only have your original flight, no one else is impacted. But as soon as you start scrolling over to the right, you can see how other flights start to get impacted, and it very, very quickly explodes. So at half an hour, we have about 10 other flights impacted. Sorry. 50 minutes, we have, it really just explodes. And then we added up top, you can also see the total number of passengers impacted. once you get to about 90 minutes, you can see that over 10,000 passengers are impacted by this delay, the original delay. It's really a nice visual way to see how primary delays impact everything. And now Juan will tell you all about how we incorporated cost into our model.
Okay, the cost of the delay basically are from four sources. One source is the cost of the soft cost of due to the passenger dissatisfaction, and the other cost is fuel consumption. The other cost is hard costs. The hard costs means the cost that the airlines input when once the doing alternative measures for to delay flights, and the other cost is the crew cost. Yeah.
Yes.
Okay. I am going to show you how the soft costs behave. Okay. Soft cost is typically has the behavior of a singular function. In the beginning, they are not too much satisfied. It's a dissatisfaction for the delay. However, if the delay increase, the dissatisfaction level increase until some point that the passengers are totally dissatisfied, and probably they decide not to buy a ticket for the next trip. So this cost affect the future revenue of the company. Okay, this is a form that show the propagation of the delay from the primary delay, and at the same time show a chart beside how is the evolution of the total delays and the soft cost. Notice that the soft cost has at the end has a stable behavior, reaching near a maximum level. Okay. Yeah, this is the simulation for the highest risky flight. For few primary delayed minutes, quickly increase the delay flight in other airports. Okay. Okay, this is a part that shows the computation of the expected value of the soft cost. Yeah. Here we have this grid show the output of the neural network. This is the behavior of the delay, the behavior of soft cost, and the probability distribution there. Okay.
Yeah. Take over. So what you saw with the soft costs is based on a survey that the airline actually did. And well, what this tool did that Juan presented is it kind of shows us an estimate. Well, we have a certain quantifier for the impact of delay, but it's not yet in form of euros. And what the company is really interested in is the price per minute per passenger. Not too long ago, we were given a table containing, I think, 5,000 records, something like this, with actual costs that they had over the years 2018 and 19 that were actually tied back to delay or cancellation as causes. And then they have many other labels such as hotel costs, food costs, EU compensation measures, etc. And because we're not quite done yet, the next task we have is to kind of make sense of this data and feed it into the tool that we had, such that when we increase the number of minutes of delay, we can actually see how that impacts the amount of NOC per passenger per minute that are generated. And as we can see here, this is the EU compensation, so that this is actually determined by policy. I think after 200 minutes of delay, the passengers are entitled to a certain amount of money or to get a refund on their flights, for example. And then, so that one will be kind of easy to model because it's determined by law. But the hotel and food costs are kind of the interesting ones we're looking at the moment. Here you can see what is that, the total amount of money spent over the years per hour of day. And you can see that the later it gets, the more money was spent on hotel costs, for example. So that's a very simple correlation that seems to emerge visually. The fact that it goes down after 8 might be that there's less transfer passengers in the late flights, so they somehow get home safely, or that there's fewer flights. This is for food. We see kind of spikes happening at 2 and around 6. Those might be the times of the day where they actually have to provide meals for the passengers. But so these are very simple first kind of visual correlations that are emerging. And we're running classification trees now over this to see if we can find make more complex sense of the data to then add it to the tool that was shown. That was it. I think the fuel costs were talked about already. Fuel costs come in when the airline chooses to speed up in order to avoid delay, which increases fuel consumption and of course has an impact on the costs.
Just one final thank you to Wim, who wasn't able to come today. He's on a flight. Ironically, he's on a flight. Our partner from CSI, our partner or our client, and then Peter and Ward in the back, our partners, who have been so helpful, and we're so grateful to have had you in the last 2 semesters. The airline data and analytics team, they've been really helpful throughout this whole process. Obviously, our Emergent family, love you guys. Last but not least, Red Bull, our sponsor. Just kidding.
Alright, that concludes the evening. Thanks to all the teams that brought their beautiful presentations. I think they each brought a really compelling and interesting story and really showed all the different possibilities data science and AI has. It proves that this is definitely not the end of Emergent, and there is still so much to be explored with our beautiful organization. If you're interested in Emergent, please follow us on our social media, and you can also join our community group where we post all kind of stuff that is data science and AI related. We hope to see you again next semester for the new academic year. We will be back with more interesting projects and more interesting events. And to end with, if you're interested in joining this cool club of nerds, which is Emergent, you can still join us. We're still recruiting for new board members. So please contact Michiel, who is in the back, or just send us on our socials. Doesn't really matter if you want to join. And now we move to the most important part.
I want to maybe say a little word because this isn't prepared. Yeah, I know. I'm usually not the guy to like take the stage, but more like cause the drama. So let's cause some more drama. 2 years ago, together with Branko and Yannick, we decided to start this random branch, and Liam decided to take on like these 3 dorks from West Flanders. And this is the first real life end event we have been able to organize, so it's really nice to see where we've come from like 2 years ago until now. So I would like to thank every consultant who has been participating over the last 2 years, every partner, every client, but also my team, Anya, Branko, Yannick, and Dionis, who's waiting with drinks and food upstairs. So thank you all for coming.